sklearn, model selection, KFold. Description. KFold is a cross-validation technique that partitions the dataset into KFold subsets. In each iteration, one fold is used as the test set, while the remaining K1 folds are used as the training set. This process is repeated K times, ensuring each fold serves as the test set once. Inputs. N splits the number of folds to create. Determines how many times the cross-validation process is repeated. Shuffle Boolean indicating whether to shuffle the dataset before partitioning. Ensures data is randomly distributed across folds. Random state and integer seed for random number generation. Used to control the random shuffling of the data. Allowing for reproducible results. Outputs. Generator returns an iterable object that yields indices for training and test sets in each iteration of the cross-validation process. Steps. 1. Divide the dataset into K folds. 2. In each iteration, select one fold as the test set and the remaining K1 folds as the training set. 3. Train the model on the training data and evaluate it on the test data. 4. Repeat steps 2 to 3 for each fold. Metrics. Accuracy percentage of correctly classified instances. Precision proportion of correctly predicted positive instances out of all positive predictions. Recall proportion of correctly predicted positive instances out of all actual positive instances. F1 score harmonic mean of precision and recall. AUC area under the curve measures the model's ability to distinguish between positive and negative instances. Visualization plots. Confusion matrix visual representation of the model's predictions, showing true positives, true negatives, false positives, and false negatives. ROC curve plot of the true positive rate against the false positive rate at different thresholds. Precision recall curve plot of precision against recall at different thresholds. Fine-tune parameters. N splits experiment with different values to find the optimal number of folds for your specific dataset and model. Shuffle set to true to ensure random data distribution across folds. Random state use a fixed integer to make the cross-validation process reproducible. Uncertainty methods. Bootstrapping sample with replacement from the original dataset multiple times to estimate the model's uncertainty. Bayesian inference use Bayesian methods to estimate the posterior distribution of the models. Parameters. Providing a measure of uncertainty. Challenges and fixes. Challenge 1 data imbalance in folds. Sample use case if the dataset is highly imbalanced, e.g., 90 negative instances, 10 positive instances. K-fold might create folds with unequal proportions of positive and negative instances, leading to biased evaluation results. Fixes to challenge 1. Stratified K-fold ensures that each fold has approximately the same proportion of instances from each class. Oversampling or undersampling adjust the class distribution in the training data before applying K-fold. Challenge 2 small dataset size. Sample use case when the dataset is small. K-fold might create folds with insufficient data for training and testing, resulting in unstable model performance. Fixes to challenge 2. Increase the dataset size, collect more data if possible. Use a different cross-validation technique, explore alternatives like leave one out. Cross-validation LOOCV or repeated K-fold, which might be more suitable for smaller datasets. Combine K-fold with other techniques. Combine K-fold with data augmentation methods to create more training samples.